We usually think of lightning as a rare, localized storm that rolls through our neighborhood. But if you froze time at this exact second, you would see between 40 and 50 massive lightning bolts hit the planet's surface all at once. Let the clock run, and that rapid-fire pace adds up to roughly 8 million individual strikes every single day. This energy focuses into specific geographical hotspots, like Lake Maracaibo in Venezuela. The storms over this one lake are so relentless that the sky lights up almost 300 nights a year. When you pull back to space and look at all this tracking data combined, the entire planet reveals itself as a continuously sparking electrical system, firing off millions of times a day. Despite measuring millions of strikes, science hits a dead end when trying to explain how the very first spark of a bolt begins. Inside a single storm cloud, millions of ice and water particles are violently colliding. This turns the thunderhead into a giant battery, separating into massive zones of positive and negative charge. Even though the cloud is charged, the highest power ever measured inside one is surprisingly weak. It lacks the strength needed to punch through the thick insulating barrier of the surrounding air. If the storm cloud itself doesn't possess enough power to ignite a bolt, something else has to provide the missing energetic kick. The leading suspect for that missing energy comes from deep space, a high-energy cosmic ray shooting straight into the cloud. This subatomic particle acts as a catalyst, injecting the energetic spark needed to bridge the gap and ignite the massive lightning bolt that the cloud couldn't start on its own. The strike officially begins with an invisible, jagged channel of charge, called a stepped leader, creeping downward from the sky in branching jumps. As it nears the surface, this downward leader struggles to bridge the final gap. To complete the circuit, it needs a cooperative connection from the ground. Objects on the ground, like trees or buildings, respond by sending their own faint ascending sparks, called streamers, upward to meet it. A lightning strike is never a simple top-down flash. It is a hyper-fast, invisible handshake between the sky and the earth. The exact millisecond the upward streamer and downward leader link together, they complete the electrical circuit. That connection ignites a blinding flash right at ground level. This massive burst of energy explodes backward, racing entirely upward from Earth to the cloud. In a fraction of a second, that bolt superheats the air channel to 50,000 degrees Fahrenheit. That is roughly 5 times hotter than the surface of our sun. Because the temperature change is so violent, nearby air molecules have no time to gently expand. With the heat trapped, the superheated air has nowhere to go but out. It is violently blasted apart, creating a high-speed pressure wave. The rumbles you hear are the result of the atmosphere snapping back into place after a thermal explosion hotter than a star. So what happens to the human body when it is struck by a force hotter than the sun? Surprisingly, 9 out of 10 people who are struck by lightning actually survive. One American park ranger survived 7 separate strikes over the course of his career. Despite the immense energy, lightning rarely kills by burning. The real threat is to your internal wiring. You are a walking electrical machine, kept alive by delicate rhythmic signals firing across your brain and down your spine. When lightning hits, it acts as a massive external power overload that scrambles the circuitry your heart and brain run on. This volume of electricity short-circuits internal pathways, often resulting in lasting nerve damage, memory problems, and changes to a person's core sense of self. You are an electrical machine living on a giant, continuously sparking electrical planet. Lightning is a reminder that we are part of an active, space-triggered circuit, and the sky is capable of temporarily rewriting our wiring.